So this is a continuation of the last video. This one says state the domain and the range for each relation, then determine whether each relation represents a function. So here we're going to talk about domain and range, and then we're going to talk about if it's a function or not. So the first thing we're going to do is just take a look at domain. So we have to find the domain. So I'm just going to write DOM down here. Okay, so my domain for this type of graph is all my possible x values. So essentially what I do here, so I'm using this axis right here as my measuring stick because that's all possible x values. So and everything in between here. So all the way left, all the way right, and everything in between. That's what I'm actually looking for here. But if you notice, it looks like this one starts about here and goes all the way left. And I can say it goes all the way left because notice that this goes in a slanted direction, which means it's still going to continue that way to the left. Okay, so that tells us there it's going to start here, and this value here looks like it's going to be a -2, and it looks like it's going to go all the way to the left to -infinity. So that interval is going to be -infinity to -2, and it does include the 2. Now, anytime I write infinity, I can't include infinity because infinity is an idea. It's larger than anything I can think of or smaller than anything I can think of. And so the smallest number I think of, it's smaller than that, so I can never really attain infinity. So I use a parenthesis for that. So that's my first piece there. Now let's take a look at the second piece now. Looks like it starts here, and then it looks like it goes over this way till about there. Now when I look at that, that looks like that's going to be not -1, but +1 over to 2, 3, 4, 5, 6, 7, 8. Oh, hang on, I went too far. Let me take it back. The 1's okay, but it looks like it only goes to there. So it's going to be that piece right there. All right, so apologize for that. That's a 1 then, and that's going to be a 7. So it's going to go from 1 to 7. So that interval for that domain then over on this side, and it includes them, so it's going to be 1, 7. So there's my domain, those two pieces together. And the way we put those together in using notation is I get -infinity here, -2, I use a bracket, then I have to use this U. U means union. So I'm putting these together. And there is the answer for the domain. All right, now let's talk about the range. Now for the range, it's a similar idea. So I'm just going to put RAN down here for my range. And then now I'm looking at all my possible y values. So now I'm on this axis now, all possible y values. So how far up and how far down do I go and everything in between? So that's the idea now. So if I look at this bottom piece down here, and I always start from the lowest piece or the smallest piece. And what I mean by the smallest is the smallest values for that x or y I'm dealing with. So this is dealing with y values, so I'm going to go the furthest in a downward direction. So that's going to be, it looks like from here down to about here. And that chunk right there, that little section is going to be my interval. So that looks like it starts at -1 there if I'm going downward. So that's 2, 3, 4, 5, 6. So down to -6. So if I'm going to write that interval, I always have to put the smallest value on the left. So that's going to be the -6, just like if it was a number line. And then -1 on the right, and then a bracket. So I'm using a bracket for both of those because it includes those y values in those points. Okay, so anyways, now let's move to the upper piece here. Now for this upper piece, it starts here, and then it goes all the way up, and it keeps going. So that tells me then that it's the smallest value is going to be this one down here. So that's going to be at 2, and it includes the 2, so I'm going to use a bracket, and it's going to infinity, and with infinity I always use this parenthesis. So this is going to be the range. I got to put those two things together now. So it's going to go from -6 to -1, And I use that union again because remember, when I'm putting these together, that's the way I do it. That's the mathematical symbol I use. And that's going to be from 2 to infinity. So there's my range now. Okay, now we actually took care of this first part here. Now we're going to talk about if this relation represents a function. So we're going to need another tool for this. So one tool we need when we're actually dealing with graphs is we need the vertical line test. So here's the vertical line test. The vertical line test says a set of points in the xy plane is the graph of a function, and then it says if and only if every vertical line, so every vertical line, intersects the graph in at most one point. So no matter how many vertical lines I draw or where I draw them, I have to hit my graph in at most one point. And then if that occurs, then I can say that it's a graph of a function. Okay, so that's what we're going to use here, this vertical line test. So let's go back to the problem. So now I'm just going to start drawing tons of vertical lines here. And you can see that no matter where I draw my line, it's only going to intersect my graph in at most one place. So even here, not on the graph at all, it's at most 1. It's actually 0, which can go up to 1, right? Okay, so when I say at most 1, that means it could be 0 or 1. Okay, I can't have any fractions there. Even in there, I can draw tons of them. We see that all of those vertical lines are only going to intersect my graph in at most one place. So because of the vertical line test, I can say this is a function. So I would say a function because it passes the vertical line test. And you have to put that in there because you have to justify why you're picking a function. Because you could just be guessing and saying, oh, it's a function, I think it is. No, you actually have to write this information out because now I see that you know what you're talking about. So make sure if you're determining if something like this graph is a function, you state the reason why it's a function or why it's not. Let's say it didn't pass the vertical line test. And you say it's not a function because it did not pass the vertical line test. All right, so there's that first one. Now let's try this next one here. So for this one's a little more interesting in a sense that I don't really have a picture for this one, but I have to use what we know. So now what we're trying to do is I'm trying to determine here if this one is, if I can get two x value, well, the same x value to map to two different y values. All right, so what I would do then is I would pick a value for x. Okay, now a nice value to pick for x would be the square root of 3. Now I kind of thought about this in my head before I just threw that out there, because who would say square root of 3, right? Okay, the reason why is because if I take that square root of 3 and I square it, that's actually going to be 3. And then when I subtract it to the other side, I'm going to get a 1. And now I have a y squared equals 1. So that took a little bit of pre-thought, for sure. So that's kind of the idea here. So I'm going to pick that square root of 3 here, squared, plus y squared equals 4. Now remember, I picked an x value, and I want that one x value to go to two different y values. That's what I'm shooting for here. And we'll see what happens. So here I get a 3 plus a y squared equals 4. So now I'm going to move that 3 over. So when I subtract it over, I'm going to get y squared equals 1. And then I square root both sides. Now remember, when you square root both sides, I get plus or minus square root of 1, which is actually 1. So I get the square root of 3 that actually goes to negative 1, and that same square root of 3 actually goes to positive 1. So I picked the point, I should say the x value that I knew would work here. Now I wouldn't pick where anything larger than 2 here, because when I subtract it over, I'm going to get a negative number. And that's actually not defined there. This domain is a little bit different here. I really have to understand this graph here in order to talk about the range and the domain of this. And we're going to talk about this now. So first I'm going to say not a function. And then all that work would have supported this answer. But I need the space. But I will say not a function. So all that stuff that I took out of there is necessary to say not a function. So we did the second part first here. So now let's do that first part. So when I look at this function here, I know right away what I'm looking at because it's an x squared plus a y squared equals 4. You may not notice this, but it fits the form x squared plus y squared equals r squared. And this is a general equation of a circle. So hopefully you caught that. And if you didn't, that's okay. So that means if I'm looking at this equation here in terms of this general equation of a circle, I would realize that my r then would equal 2 because 2 squared is going to give me 4. Okay, so now all I'm going to do is draw a circle of radius 2. So there it goes. So in order to talk about domain and range, it'll be a lot easier if I graph this in this way. And now I can see what I'm actually looking at here, just like it did the previous graph. And when I look at this one now, if I'm looking at my domain, that's all my possible x values, so that will be this way. And if you notice, those x values are going to be from -2 to 2, including the -2 and the 2. So my domain then would be bracket -2 to bracket. And then my range would be the same. -2 to 2. And that's because now I'm going on the y-axis here. And that's also going to go from -2 to 2. It's a circle. So there's my domain and range, and it's also not a function.